Now let's consider this example. I urge you to pause the video and try the question on your own. Don't forget, no pain, no gain. I have the weak student in mind, so I've taken my time to explain everything so that those who find mathematics very difficult will find it very, very exciting. Mathematics is very, very exciting. Meet the teacher who can break down difficult topics into something easier and understandable. I have all the topics, that is our videos on all the topics in the WASI syllabus. Call the numbers and get a copy for yourself. Now solve, that is log 4x plus log x over 2x equal to 2. What can you see over here? I said first pause the video. I believe you've paused it and then you've tried it on your own. Now you can see that the bases are not the same. So you have to make sure that we have a common base to all of them. Now we know that we can apply the change of base. Now what does the change of base say? You see, let's suppose that if we have, let's say, log A, B, and wanted to have a base of C, this is the same as log C of B all over log C of A. Now, so we've changed to have a common base of C. Now, what is the question? We have log 4x plus log, we have x over 2x, and this is equal to 2. So this will change it to have a common base of 10. So applying this, this will just be log 10 of x over log 10 of 4x plus log 10 of x over log 10 of x over 2. And this is equal to 2. Now, let's note that, you see, if you have, let's say, log, let's say 10 of 2, this is the same as log 2. We can ignore the 10. If you have log 10 of x is the same as log x. So if you see log without the base, then it's the same as log 10. So this, we can rewrite this ignoring the 10. So clearly this is the same as log x over log 4x plus log x over log x over 2, and this is equal to 2. Now, what can we see here? You have log 4x. 4 is multiplying the x. We know that when we are multiplying, what do? We add. That is the laws of logarithm. When you're multiplying, we add, and when you're dividing, we subtract. Hence, this is the same as log x over log 4 plus log x. Why? When you are multiplying, you add. And this is also the same as we have our log x over, so this will be log x minus log 2. Log x minus log 2. When you're dividing, what do? You subtract. And clearly this is equal to 2. Now, laws of logarithm, let's look. You see, if we have, let's say, log, let's say 10ab, or we have log am plus log an. When we are adding the same base, what do? We multiply. So this is the same as log amn. When you're adding, the base are the same, we multiply. Now, if we have log am minus log an. Now, when you're subtracting, what do? When you're subtracting, what do? We divide. So this is the same as log am over n. Very, very important. And if you have, let's say, log apn, this is the same as n log ap. Now, so we have this equation. What can we do? We have log s, log x, log s, log x. So from here, we can say that suppose, so you can say let, or suppose log x be equal to any variable, let's say a, m, and n. So if it is equal to that, then what can we say? The numerator log x is a over log 4 plus log x. So we have log 4 plus a. And then we have plus a over log x minus log 2. Log x is a. So a minus log 2. A minus log 2. A minus log 2. And this is just equal to 2. This is equal to 2. Now, what is the LCM? Clearly, the LCM log, here we can write it a plus log 4. This log 4 plus a, we can write this as, let's say, a plus log 4. So the LCM is a plus log 4, a minus log 2. So multiplying through with the LCM, what is the LCM? A plus log 4, a minus log 2. So we take our time, and then we have a plus log 4, and then we have a minus log 2 times a over a plus log 4 plus the LCM is a plus log 4, a minus log 2. So we have a plus log 4, a minus log 2 times a over a minus log 2. This is equal to, we have 2 a plus log 4, a minus log 2. The LCM times that. Now what can we see? A plus log 4 cancelling a plus log 4. A minus log 2 cancelling a minus log 2. So in essence, what do you have? A times this. That's a times a minus log 2 plus a times this. A plus log 4. And this is equal to 2a plus log 4, a minus log 2, a minus log 2. Now, we expand using the distributive property. What does the distributive property say? If you have, it says that if you have a into bracket b plus c, a times b, ab, a times c, ac. So we want to use the distributive property. A times a, and this is giving us a squared, a times a squared, a times this minus a log 2. A times this, a does a squared, a times a squared, a times log 4 plus a log 4. And this is equal to, now we have the 2 as a constant. Let's apply the distributive property repeatedly. Now a times a does a squared, a times negative, so you have a times this, that's negative a log 2 plus this time this a log 4, this time this minus, we have log 4 log 2. Log 2, this times that, and we have our 2 over here. Now a squared plus a squared, and this is giving us 2a squared. That's a squared plus a squared, 2a squared. Now can you see we have here log 4? We can change log 4 to log 2 by applying the third rule. You see the third rule says if you have log a p n, the n can come down, so you have n log a p. So this is giving us, we can say negative a log 2 plus, now 4 is the same as 2 squared, so the 2 can, we have 2a log 2, 4, 4 is log 2, 2, and then the 2 come down. We have something like this. Now expanding, 2 times a squared, 2a squared, 2 times this negative 2a, log 2 times a here, we have plus 2a, log 4, 2 times this, minus 2, we have log 4, log 2. Wow, that's what we have. Now look at this, negative a log 2, 2a log 2, log 2 log 2, so 2a minus a, that's a, so we have 2a squared plus a log 2 equal to this, giving us 2a squared, 2a squared, and then minus 2a log 2 plus, you see this log 4, we can change this to log 2. You see, this will be log 2 to the power 2. The 2 will come down, 2 times 2a, that's 4a log 2 minus 2. Now look at this one, look at this one. Log 4 we can change to log 2. That's 2 to the power 2, and then the 2 will come down, so you have 2 here, we have log 2. We have another log 2, there's log 2. Alright, 2 times this, that's 4. So we have 2a squared plus a log 2 equal to 2a squared. Negative 2a plus 4a, that's plus 2a log 2, this and this, plus 2a log 2. And then we have minus 2. That's 2 times 2, that's 4. Log 2 times log 2. And this is giving us log 2 all to the power 2. Because if you have a times a, that's a squared. So log 2 times log 2, that's log 2 all to the power 2. Now what can we see? What can we see? You can see that you can have some common terms from here. Now we have you have 2a squared, so 2a squared minus 2a squared. Let's come in here. Now let's see, we have a log 2 plus a log 2. But this is coming minus 2a log 2. Positive crossing, that's negative. So this and this has gone to this side, equal to negative 4 log 2 all to the power 2. Now 2a squared minus 2a squared, that's 0. A log 2 minus 2a log 2, and clear that's negative a log 2, and this is equal to negative 4 log 2 all to the power 2. Want to find a, what do we divide both sides by? Negative log 2. So we have, this implies we have negative a log 2 over negative log 2 equal to negative 4 log 2 all to the power 2 all over negative log 2 all over negative log 2. Now let's see this and this cancelling, log 2 is cancelling log 2. Now this negative is cancelling that. Now this is log 2 to the power 2. So we have a will be equal to 4 log 2 all to the power 2 minus 1. Why? Indices, when the bases are the same and you are dividing, we subtract the exponent. So let's see, log 2 to the power 2 over log 2. So that's log 2 to minus 1. And this is the same as 4 log 2, because 2 minus 1 is to apply the third law. The 4 will go to the top of the 2. So this is basically log 2 to the power 4, and this is log 16. It's just log 16. But we said that Look here, what did we see? Log x is equal to a. But a is equal to log x. We had a to be log 16. So we have log 16 equal to log x. We want to find x. Therefore, x is basically 16. X 16. So x is equal to 16. Isn't it very, very easy? No pain, no gain. If you don't understand, play back for better understanding. Now let's go to the beginning and then let me explain everything all over for those who don't understand. I have the weak students at heart, so I take my time to explain everything they need to know. Now let's see. Looking at the question, we said solve, that is log 4x of x plus log x over 2 of x equal to 2. And clearly the bases are not the same. 4x, x on 2. So we use change of base principle and make sure that they are of the same base. You know, from the change of base principle, if you have log AB and you want to have a common base of C, that will be log C of the top one over log C of the down one. And there's it. And I give examples over here. So this is what we have. We want to change the base to have a common base of 10. So log 10 of x over log 10 of 4x plus log 10 of x over log 10 of x over 2 equal to 2. Now, log 10 of x is the same as log x. Now, and then log 10 of 4x is the same as log 4x. So this is the same as that. Now, you see, laws of logarithm. When you are multiplying, you add. So log 4x is the same as log 4 plus log x. And when you are dividing, you subtract. So you have log x minus log 2. Now, so from here, that is from the laws of logarithm. We said if you have log an plus log an, because we are adding, you multiply. And then if you are subtracting, log an minus log an is log am over n. So when you're subtracting, you divide. When you're adding, you multiply. Now the third law says if you have log ap and this is n log ap. So this is what we have. What can we do? You can see log x, log x, log x, log x. So you can see that let or suppose log x is equal to a. So wherever you see log x, we call it a. So this is a plus log 4 plus a. So a, that's the log x. Log x is ra, log x is ra. So you change it to a. So wherever you see log x, you put a over the addition is commutative. This should have been log 4 plus a, but I have interchanged to be a plus log 4. So we have this nice equation. What is the LCM? LCM is a plus log 4, a minus log 2. Multiply through with the LCM. So when you multiply through with the LCM, a plus log 4 will cancel out. A minus log 2, a minus log 2. So this and that will cancel out. And then this is also multiplying over there. So we have a times this, that's what we have. A plus this, that's what we have, equal to 2a plus log 4, a minus log 2. So that is what we have over here. Now we expand using the distributive property, but then we also apply the third law. You see, we have log 4. You see, if we have, that is this, that's this. If we have log a, p, and that is n log ap from the third law. So if you have, let's see, log 4 is the same as log 2 to the power 2. So the 2 come down and we have 2 log 2. Very important. So over here we change this 2 to the power 2, so the 2 come down here. You have this. And then this log 4 also over here, we change it 2 to the power 2. So this will come and this will give us 4 because 2 to the power 2, 2 times 2a, that is 4. And this one is 2 to the power 2. So the 2 will come down. You have 2, 2, this 2, 2 to the power 2. We'll bring the 2 here and then we have this. Now log 2 times log 2, that's log 2 to the power 2. 2 times 2 giving us 4. So this is the equation that we have. We simplify, grouping like terms, and then we have that. Now we have negative a log 2 equal to negative 4 log 2 all to the power 2. We want to find a, we divide through by what is multiplying the a, which is negative log 2. That's what we have here. Now this negative will cancel this, log 2 cancel log 2, we have a. Now this negative cancelling this, log 2 to the power 2 log 2. So 2 minus 1, because this is to the power 1. 2 minus 1. In this is when the base are the same, we are dividing. We subtract. Now clearly 2 minus 1, that's 1. So we have 4 log 2. And this is the 4 will go to the top using the third law. So log 2 to the power 4. And then 2 to the power 4, that is 16. But we know that a is equal to log x. So log 16 equal to log x. And clearly log 10, 16x, so x is equal to 16. I have all the topics in the WASI syllabus on pen drive. I've taken my time to explain everything. I've solved very challenging questions. I've taken my time to explain so that the weak students will understand. Call the numbers you see on the screen for a copy of the lesson. On pen drive, it is very, very affordable.